Let's go to guided practice 4. The aircraft for a particular flight has 72 seats. The airline's records show that historically for this flight, only 90% of the people who purchase a ticket arrive to board the flight. They assume this trend will continue and decide to sell extra tickets and hope that no more than 72 passengers will arrive. The number of passengers that arrive to board this flight is assumed to follow a binomial distribution with a probability of 0.9. The airline sells 74 tickets for this flight. Find the probability that more than 72 passengers arrive to board the flight. Define random variable x follows binomial distribution with 74 as the number of trials and 0.9 as the probability. We are looking for probability of x greater than 72, which is the probability of x greater than or equal to 73. Let's go to calculator. Go to menu 6, 5. We are looking for binom CDF, so go to B. N is 74. Probability is 0.9. Lower bound is 73. Upper bound is 74. Enter. Answer is 0.003791. Let's go to B1. Write down the expected number of passengers who will arrive to board the flight if 72 tickets are sold. Since this time n equals 72, we will define another random variable. Y follows binomial distribution with 72 as the number of trials and 0.9 as the probability. We are looking for expected number of passengers, which is E of Y equals N times P. 72 times 0.9 equals 64.8. Let's go to B2. Find the maximum number of tickets that could be sold if the expected number of passengers who arrive to board the flight must be less than or equal to 72. Keywords here is expected number. N times P less than or equal to 72. Probability is 0.9 less than equal to 72 divided by 0.9 both sides. N less than or equal to 80. So maximum number of tickets is 80. Each passenger pays $150 for a ticket. If too many passengers arrive, then the airline will give $300 in compensation to each passenger that cannot board. Find to the nearest integer the expected increase or decrease in the money made by the airline if they decide to sell 74 tickets rather than 72. In other words, the increase or decrease in the money should be compared to 72 when you sell 74 tickets. The airline sells 74 tickets. Could be all 74 people come to board the flight. It could be only 73 passengers who come to board the flight, or less than or equal to 72 passengers who will come to board the flight. When airline sells 74 tickets instead of 72 tickets, income will increase by 74 minus 72 times 150. But when 74 passengers come to board the flight, the airline has to pay 2 passengers $300 each as a compensation. Therefore, you need to minus 300 times 2 equals negative 300. If 73 passengers come to board the flight, we still have 74 minus 72 times 150 as the increase in the money. But you have to pay $300 as a compensation. We got 0. If less than or equal to 72 passengers come to board the flight, the company will get 74 minus 72 times $150 as the income increase. And the airline won't give any passenger the compensation, equals 300. For the probability, this T follows binomial distribution with 74, 0.9. We are looking for probability of T equals 74 equals, go to calculator, we got 0.000411. For probability of T equals 73, by calculator we got 0.00338. For probability of T less than or equal to 72, go to binom CDF, we got 0.996209. Therefore, the expected increase or decrease in the money equals negative 300 times the probability of T equals 74 plus 0 times probability of T equals 73 plus 300 times the probability of T less than or equal to 72. Negative 300 times, go up, enter, plus 0 times go up, enter, plus 300 times, go up, enter, enter. Answer is 298.739. But let's go back to the question. To the nearest integer, which means we need to change this into integers. We got 299.